All right, looks like we should be live with today's webinar. For those who are just joining us, which should be pretty much everybody because we just started it, we're going to give a minute or two for people to join before we kind of kick off and get into today's presentation. Thank you so much for taking the time to join us. We're excited to talk to you today about the new CIS API Security Guide. Like I said, we'll give it a minute or two and then we will kick things off here momentarily. All right, looks like we've got some people joining. Awesome. And we will just another 30 seconds maybe, and then we'll kind of kick things off here. Excellent. All right, we've got confirmation. We should be good to go. Might have a few more people coming through as we get going, but no worries for anybody joining today. And if you missed the first couple of minutes or anything, and I'll repeat this towards the end of today's webinar, don't worry. The live stream is being recorded. It will be available for replay after the event for you to go back and look at anything you might have missed if you happen to lose connectivity for a moment or anything during this, or if you want to share it with a friend, a coworker, a colleague, whatever, all of this will be available for replay. And also for anybody who signed up for the webinar in advance and registered for it, you will be getting an email after today's webinar with a link to the slides that we use in the webinar, as well as a link to this recording and a link to the CIS API Security Guide, which is kind of what we're here to talk about today. So just to kick things off, my name is Snyder. I'm one of the co-founders here at FireTail. I'm joined today by our VP of Product, Timo Rüppell. Timo, say hi.
Hi there, everybody.
Awesome. Thanks for taking the time to join us today, Timo. You worked on this a lot. So this is kind of your baby in a way that we're launching out into the world, and we're very excited to be talking to you about that today. So let's first go over a couple of housekeeping items for today's webinar, as well as some logistics and our agenda for today. So from a content perspective, what we're going to talk about today is kind of the current state of the API threat landscape. We're going to talk about some existing tools and resources that are out in the world, like the OWASP API Security Top 10. We're going to talk about the motivation for the CIS API Guide, as well as the content of the API Guide, as well as some best practices and some tips for how your organization could go about starting an implementation process around the guide, if that's something that you choose to do. We will have plenty of time towards the end of today's presentation for Q&A. We've got the webinar scheduled for about 45 minutes. I expect that will be closer to the 30 to 35-ish minute range. So don't hesitate to drop any questions in the chat. You should see a sidebar towards the right-hand side of the screen. Please do drop questions in there as we go. Like I said, we should have time to cover, a fair number of questions toward the end of today's presentation. Again, the webinar is recorded, so don't worry if you miss anything, and you will get access to the slides as well. And I think by way of logistics, that's pretty much all there is to know. So without further ado, let's get started on kind of introducing ourselves, and let's get started into today's presentation. So I will just start by introducing myself. For those who don't know me, I'm Jeremy. Like I mentioned, I'm one of the co-founders. I'm more on the business side over here at FireTail, although I do consider myself a business person with a strong technical background. Earlier this year, I retested for my certified solution architect from AWS, and I passed, yay, with flying colors, while having COVID, by the way, which was a lot of fun. But, I've been in the IT and cybersecurity world for just over 25 years now. I've pretty much spent my entire career in IT and cybersecurity. I've worked for a variety of companies, everything from small SaaS vendors to video game companies to larger companies like AWS, and spent more than the last 10 years in the cloud. So that's a little bit about me. Timo, why don't you take a minute or two and tell people about who you are and where you come from and how you came to this crazy world of API security.
Absolutely, Jeremy. Thanks. Yeah, so I'm originally hail from academia. I'm a trained and dyed-in-the-wool particle physicist. So any questions about black holes and string theory are also appreciated, and maybe I can answer them in my free time. after the end of this webinar. But yeah, so after having gotten my PhD, I started looking around for something more interesting to do, and I fell into the wild world of startups, and this is basically like the third or fourth time round that I'm participating in building products, building a company, and having fun with it. And yeah, that's it for me. Go ahead.
Awesome, and we're really glad to have you on board, Timo. And I know API security is something that you had to look at some of the other startups that you worked at along the way. So we're really thrilled to have you on board and working with us on shaping the vision of our product. So that's been awesome. Okay, so I'm going to kind of kick off today's webinar talking about the API threat landscape. And if you're attending this webinar, you probably already have something of an interest in API security, the overall topic of API security. But I want to share some information around some of the research that we've done over the last couple of years here at FireTail to really help understand in more concrete terms just how big the threat is and what the nature of the threat is towards APIs that organizations are creating and producing. And to kind of start things off, I want to just give this example that I give pretty often, but just to kind of frame like why APIs are so important in the modern internet landscape. So this is an example of kind of a small scale itinerary for, maybe this is a weekend getaway, maybe this is a longer vacation, whatever it is. The point of this is that when you're planning something like a vacation, you can go to one single site, and that might be, let's say, Expedia if you happen to live in the US like I do. That might be booking.com if you're in Europe, or Agoda if you're in Asia, or any number of other products or so-called OTA, online travel agencies around the world. And you can book flights, you can book hotels, you can book rental cars, you can book tours, you can book experiences, etc. Very often all through one location. And if you think about what's happening in this kind of web of transactions, what to you is one itinerary composed of all these different services is probably well over 20 to 30 coordinated touch points between multiple third parties, right? So I often ask the question when I present this to a live audience of how many have you ever flown on Expedia Air or stayed at Expedia hotels or rented a car from Expedia Rent-A-Car? And the answer is none of you ever have, because those services don't exist. And yet you all know the brand name Expedia. You all know the experience of booking through Expedia, or again, its equivalents in other parts of the world. The travel industry is a hyper-connected example of a fragmented space with many providers who fill particular niches and services, and they're all connected to each other over API calls. And so when we go through building this itinerary, we'll literally be in the hundreds of API calls back and forth between the providers to do things like, look for flights, look for flight pricing, look for flight availability, book the flight, book seats, add meal requests, add luggage, whatever it may be, add travel insurance. This back and forth ping pongs of interactions between these parties really is kind of representative of how not only the travel industry functions online, but how many, many modern internet services are built. And when we think about some of the implications there, then you can start to understand why the security of these API connections is so important. When I'm going through putting this itinerary together, I'm sharing information about, all of my personal details, my home address, my first name, last name, email address, etc. But I'm also sharing very often very personal details, like many hotel reservations and many international flights, of course, require my passport information. There arguably is no more personally identifiable piece of information that you possess than your passport. And then similarly, I need to pay for all of this. So I need to put in my payment credentials, most likely a credit card, but could be bank transfer information or some other form of payment. Again, extremely personal and extremely critical. And all of that information is being sent over APIs. So just to kind of set the context for why we think API security is so important in the modern internet, I think this is a useful example to go through. And then just to kind of build on that, why are APIs so important? And, I think it's around 10, 12 years ago now, there was a famous memo that came out of Amazon just before my time there about the API mandate. and how Amazon recognized that they had a problem that many parts of the business weren't effectively communicating data with each other. And there was an internal memo that's now been, famously leaked and circulated on the internet. It's nothing confidential or private anymore, but it was basically stating that organizations needed to make it possible for any other organization within Amazon to query and interrogate their data. And so kind of a common example of that would be like, let's say the Kindle business unit and then the Amazon.com retail side wanted to be able to share data back and forth, but they lived in these kind of data silos. What they ended up realizing was that by exposing the data from one side to the other and vice versa via APIs, either side could query the other, get the data that they needed, not impose this burden of having to try to coordinate calendars, set up internal meetings, go through formal requests for information, but just make the data available. Over time, that model has become so common on the internet, you now see full companies who are built around the concept of making a service or a data stream available solely via an API. Some common examples of this are services that you probably don't realize that you're using every day, but as a consumer, you are probably every day getting some interaction with, let's say, a company like Twilio, who might send out SMS notifications with one-time passwords, or with a company like Stripe that might process a payment via an API call from some other service that you're buying from. That could be, ordering food, that could be paying for a taxi service, who knows what, right? APIs allow you to kind of put together modern internet services faster with fewer internal resources. They allow you to outsource some of these complex functions, and including things like, let's say, payment processing is a very complex function that has a lot of compliance requirements and security overhead to building out that service. But you don't have to build that. You can simply integrate it via API. That's why on the right side of the screen here, what I tend to think of APIs are, or as what they enable, as this flywheel of value. You can build services faster, quicker, and better with fewer resources by leveraging API connections to all these other providers. Along with that, of course, though, API security risks are growing. So as the overall adoption of APIs is up across the broader internet, so are the number of threat actors who realize that there are good targets on the API side. So we have a API data breach tracker on the FireTail website. You can find it linked kind of from the footer navigation of our website. So if you just kind of scroll down to the bottom of the page, you look for API data breach tracker, you'll find it linked there. We've been cataloging over the last couple of years the history of publicly disclosed API breaches, and we've been trying to classify them along a couple of different parameters to understand in each situation or scenario what went wrong and what could have been done better or differently to protect and defend that API. We've put all of that analysis together. So for anybody who's interested, by the way, just like scroll down to that tracker and find it. You will also find a report that summarizes the data, as well as a little bit of additional information that we put into the report to kind of not only based on the data tracker, but based on, let's say, data from some FireTail customers, data from the public internet, et cetera. And you'll find that as the FireTail State of API Security 2024. It's available on that page completely free. I would invite anybody on the webinar who's interested, just go ahead and check that out for yourself. But a couple of other things that we've realized, the rate of attacks against APIs has actually been growing dramatically over the last couple of years. So for 2023, the last full year that we have data for, they were up about 7x over the previous year, so 737%. Well over 1 billion records have been breached or at risk of breach. That's classified in there as well. And then one really interesting data point on API breaches in particular, as compared to other types of data breaches, is that API data breaches tend to be much larger. And the reason for that is typically when we see a problem with an API, it is kind of a systemic problem. There's some kind of business logic flaw with the API that allows an attacker to exfiltrate or extract all of the data from behind the API. So when we looked on the classification side, and you'll see this again if you look at the tracker or if you read in the report, authentication and authorization problems are by far number 1 and number 2 root causes. But this categorization right here that you're seeing on the screen right now, this is in terms of number of events. When we shift that view and we calculate instead based on number of records, we see that authorization really kind of takes the cake. sort of pun intended, since we're using a pie chart here to represent the data. But authorization is really kind of by far the #1 threat against APIs. And so if you're not looking at good authorization methods on your APIs, just be aware that that is well known and well abused out in the real world. Awesome. Okay, so just quickly before I wrap up and hand over to Timo to talk about the CIS security guide, a couple things I wanted to talk about in terms of framing. Why did we look at putting time, effort, and energy into partnering with the Center for Internet Security on creating this guide? Well, many of you are probably familiar with the OWASP API Top 10. And it's been around for a little while. V1 came out in 2019. There was an update in 2023. You can actually see a little bit of the changes between those 2 years. There were some positive changes, certainly from our perspective, in terms of the fact that authorization and authentication remained the top 1 and number 2, but seeing that there were some additional points, and I'll actually go back for a second. If you kind of compare the two sides, you'll see that there's additional authorization risks identified in the 2023 version. And so that's been positive to see. But one of the common criticisms that we heard very often from customers who are, let's say, looking to start an API security initiative within their organization is that OWASP API Top 10 is really a list of risks. It's not a set of controls, and it's not a set of actionable guidelines, which was very often what they're looking for. So they might pull up this OWASP API Top 10 list, and then they start looking down the list, and they're like, okay, well, there's a risk around broken object level authorization. First of all, what is that? And to be fair, the OWASP API Security Top 10 does describe what it is. But how do we check for that? How can we systematically or programmatically look to see whether we are at risk of that? And that is where the problem starts to set in with organizations. It's like, this is telling you all the things that can go wrong. But when you want to try to start the process to examine your own organization and figure out where your risks lie, this becomes more of a set of guiding principles and not something that is actionable. And that's one of the key criticisms that we heard time and again around the OWASP API Top 10. Kind of one of the last things from my side to mention, just because of the time frame for when we're presenting this webinar, and in fact, when we rolled out the CIS guideline, we actually started the CIS guide effort before we had our first case of regulatory compliance action around API security. So earlier this year, this is being recorded in August of 2024, but earlier this year, there was a company called TracFone that entered into what's called a consent decree with their regulator, the Federal Communications Commission, or FCC, that recognized a number of security flaws that TracFone had. And as part of this consent decree, TracFone agreed to improve its cybersecurity activities. And in particular, API security was called out for the first time, which was really interesting and certainly positive from our perspective as people who have been kind of out there telling the world how important API security is for a couple of years now. It was great to see some kind of federal recognition of how critical APIs are in the modern internet. But then where it started to get a little bit funny from our perspective is, as you read through the consent decree, it tells you, hey, mitigate against these OWASP API Top 10 risks. Well, great, but we just got done talking about the fact that that's a risk model, not a set of controls. How do you measure that, right? It leaves it very open to interpretation. And secondarily, one of the other things that they said was follow NIST guidelines. Well, there is no NIST guideline for API security. The closest thing that exists is something called the NIST 800.204. It relates to something called microservices, which is kind of an architectural concept, very, very closely related to APIs, but not necessarily. And in fact, the NIST 800.204 guidelines cover a different set of risks around things like API gateway configuration, and not around some of the things that are most critical to API security, like, again, these design and business logic flaws with regards to things like authentication and authorization. So on the one hand, we were super excited to see that, okay, there's recognition finally that there's a critical component here in APIs. But on the other hand, does this consent decree really point an organization in the right direction? We're not sure. So with all of that said, we hope the new Center for Internet Security API Security Guide can be helpful to any organization. And hopefully that gives some good background information on kind of what we did and why we started this project. And with that, let me hand over to Timo to talk about the guide.
Thanks, Jeremy. Yeah, so let's dive into a little bit around the CIS guide that we started together with the Center for Internet Security. So, as Jeremy said, the impetus here was really trying to find prescriptive guidance for managing, for creating, for designing an API in the correct way. And as a company, that's sort of like our origin story was around making it possible for people to run their APIs safely. And so when looking around, we actually discovered that there aren't any such standards, as Jeremy already pointed out. And specifically, we looked for some of these in CIS. And if you're sort of familiar with IT security, you probably have run into CIS benchmarks. These are sort of technology-specific benchmarks that are usually intended to be programmatically checkable. So you've got like a CIS benchmark for AWS, for example, or for Azure, or for some particular software. And these are really sort of created as ways to enforce best practices. And that's sort of what we were trying to look for APIs. Now, the thing when we started talking with CIS about this is that APIs as a general concept are not sort of a specific technology. Like there's an AWS gateway, for example. You can run your APIs on Kong or Teak or some other service. You can run a Kubernetes cluster, etc. So from that perspective, CS just said that there's something like that wouldn't exist, right? But they did come back with the sort of fact that they have actually done a similar thing previously around supply chain security, which again is like a high-level concept and doesn't relate to any particular technology specifically, but is a thing that is increasingly important in IT deployment and development. And so that's where we started with this sort of security guide, which is why this is not a benchmark in itself, but it is a high-level sort of 10,000 feet overview of best practices around API security. And the general idea is that the guide does contain prescriptive and actionable controls. However, these are intended to serve as sort of starting points, for example, later creating a technology-specific benchmark, for example, for AWS Gateway. And so with that in mind, sort of we started creating this and actually published it less than a month ago at Black Hat. And since then, there's been an influx of interested people in CIS benchmark. So this is developed with the community very much as a collaborative effort, and we do welcome everybody. You need to sign up for a CIS account, but otherwise participation is free and very welcome. There's a link there, and you can also just find it by looking for API security on the CIS benchmark site. But sort of to close out this sort of introduction, the idea really is that this should be the starting point for either technology-specific benchmarks, or if you're a company and you're really, as Jeremy said, trying to figure out how to do API security. What do you actually need to do when you're trying to build out a security strategy around your APIs? This is a document that you can take a look at and then, start figuring out the policies that you need, start figuring out the processes that you need to implement, and get actually good guidance for those. So with that in mind, let me just quickly go over like the large-scale structure of the guide. We decided to divide the sections along the dividers of the API lifecycle. So partially this is because it's sort of a technology agnostic way to divide these things again. So it doesn't really affect later benchmark creations necessarily. And it's also a good divider that is commonly how teams at a company, for example, deal with the API. You've got a separate operations team, you've got a separate development team. So when you're trying to figure out how to implement policies regarding API security, you can just basically point your dev team at a certain section of this guide. They don't need to read the entirety of the guide to be able to understand what is sort of important for their aspect in the work. So we start off with the design phase, and in the design phase, obviously the most important thing that we've identified so far is to have good documentation. So having a specification document that is machine readable, that can help you with defining your API, defining data models, defining access models, etc. That is a key element in the design phase, among others. Going over into the development phase, where it's obviously important to handle identity and access management and session management. Again, security functions and error handling is in here. I should point out specifically that this is not a guide about sort of development best practices as is. There's like, that is a whole other ballpark. So the development section of the API security guide focuses specifically on issues that relate to how to develop an API. What are the important security considerations when developing an API, instead of just listing the sort of normal just programming best practices, which you should obviously also follow. So after development, moving over into the deployment phase, where asset management is increasingly important. Versioning is absolutely important. You should have good incident response planning, RTOs and RPOs, etc. And then the operational phase, where performance and availability monitoring is important, making sure that you're properly logging your data, data retention, and regular vulnerability and penetration testing, etc. So those are all parts of the operational phase. And then finally, decommission, which again is often forgotten, but is actually like a critical element when looking at some of the incidents that have happened, where decommissioning has gone awry and stuff keeps popping back up. You hear about zombie IT and zombie APIs and ghost APIs. This is basically what happens when decommissioning doesn't work as planned. So steps around planning, mitigation strategy, communication, the actual termination and cleanup, and then also validation of the termination are all parts of this decommissioning bucket. So next, I'm going to go through some of the items in the guide and try to mention and sort of illustrate how a tool like FireTail can help you implement these steps. So let's start from the design phase here. So as already pointed out, the key element in the design phase is having a documentation format for your API. This serves as a single point of truth, a thing that all the different teams can refer to, a thing that hopefully can generate documentation, a thing that can help you later in the development phase. And so one of the best solutions for this is Open API specifications, formerly known as Swagger. There are some other alternatives that are also available, which are equally good and have equally good tooling support. For FireTail, we chose Open API, and we provide a couple of different ways to help people get started with an Open API specification, because we do realize that some people just don't have it ready, right? They already have a service that's running in production. They already started development 10 years ago, and they don't have an Open API specification for what's how do we help these people? So the two ways that we do this is, one, we do log-based spec generation. So you hook up your service to FireTail, you start ingesting log into the FireTail platform, and after a quite short time, we will be able to start generating an API spec based on those logs. So we analyze the logs, we see what are successful requests and responses, and we basically construct an API specification out of those. And this is, again, will help you get started with it, and then you can start importing and implementing tooling around the Open API specification, taking it into your processes, and sort of getting into best practices that way. The other way that we do is specification from code, where we have a tooling and system to get integrations with your code repositories, and then basically doing static code analysis or for some languages, and as a sort of very new feature, doing some large language model-based analysis for some other languages to basically look through your code, identify points in the code that handle requests, and then extracting sort of, routes and route parameters, query and response formats, etc. out of those. That's sort of the idea behind our push to get everybody to use OpenAPI specification. Yeah. All right. Next one is the development phase here. Here, one thing that is really important is that in the design phase, you might have all of your best intentions in hand, and you might have laid out plans. And then when you start developing, usually sometimes things get lost and you lose sight of what is important, what needs to be done. So here, FireTail can help you by doing continuous integration into your CI/CD pipeline and using the, for example, code to spec capabilities, or just FireTail GitHub Actions that let you upload the existing spec files into FireTail, where it becomes part of our findings engine. So the finding engine is invented and created to address the most important part of API security, which is finding design flaws. Design flaws with your authorization, design flaws with the way that you've built your API, with the way that you've designed your API. And this is crucial. So by incorporating like a CI/CD hook, for example, you can ensure that you're actually staying within the defined limits of how you want your API to operate, right? So for example, you might get alerts of, somebody has made a change, and now suddenly there's an endpoint that uses numerical IDs, although you decided in the design phase that you wouldn't be using numerical IDs anywhere, right? So these are the kind of things that we can then help you with and get these sort of findings again fed back into ticketing systems or Jira or sort of like straight back to the development team and sort of facilitate a really fast turnover for these sort of like design oopsies that might happen during development.
Yeah, and Timo,
then the next step. Yeah, go ahead,
just real
Jeremy.
quick before you move on, I just wanted to really highlight that point that I know you made and said explicitly, but like this point about ironing out these design flaws early during your API kind of build and pre-deployment lifecycle will actually save you so much heartache later on. I mean, if you can get away from, having unauthenticated endpoints, if you make sure that there is an authorization check on every API request, and you don't have sequential numerical IDs, you're taking like the top 3 steps right there to eliminate the risk of what's called BOLA, broken object level authorization, which is the single flaw responsible for the vast majority of data exfiltrated and breached via APIs. So getting it right early during this phase is just, you just get so much benefit for it.
Yeah, I think you're cutting out like 95% plus out of the pie slices that you showed if you do just those 3 things, for example. Yeah. For sure. Yeah. And yeah, I like to think of this as exactly like this, an early warning system, making sure that some of these design flaws just don't end up in production, for example. All right, so next step would then be deployment. Here, FireTail has a feature that's called Actions. So again, tying into the sort of event system that FireTail has, where, for example, an event can be that you have a CI/CD hook that uploaded a new spec to FireTail. What you can then do is you can trigger FireTail actions off of those. We do provide managed actions around testing your API. So this can become part of your normal deploy cycle. So we do tests for SSL configurations, for data exposure, endpoint security, CVEs, fuzzing. We even do contract testing based on the API spec that you have. So making actually sure that your API behaves as is intended, right? On top of this, we also provide just blanket Lambda function runners. So if you've got your own security playbooks, if you've got more extensive testing that you want to write yourself, these can all be triggered from within FireTail, and they can then return findings into FireTail, which again become part of this early warning system, become part of the posture management around your API security. So really important part, and sort of a quite interesting feature of FireTail as well here. And then the operational part, here FireTail can definitely focus and help you with the logging and metrics around your API. So first of all, FireTail gives you unified logging, meaning if you have got different kinds of APIs, different kinds of applications running in different cloud providers, running on different hardware, running on-prem, some of them, FireTail tries to provide a solution that lets you basically log all of them into a central place, get unified log formats, get unified data enrichment for the logs. Obviously, there might be some differences in what information is available in the logs, but we try to fill out and scrape together as really a sort of unique and singular picture for what is happening with your APIs. The data enrichment includes, IP enrichment. It includes tagging by our processes. So if we detect SQL injection attempted, PHP injection attempted, if we detect other kinds of, possibly suspicious or malicious activity, these all get added to individual logs, and then these again get enriched into the APIs so that you get a really nice overview of which APIs are having problems, which APIs are showing symptoms of being under attack, for example. It gives you a good overview of your real estate and a good overview of what's happening with your APIs. And then obviously we do have a very, very fully featured alerting and automation system there. So you can basically, figure out what you want to alert on, figure out what are the patterns and bad behaviors that you want to be aware of, and then, shoot them off into Splunk, into Jira, Slack. We're also coming out very soon with an integration to enrich back into Wiz, for example. People or Wiz customers might be very interested in this. So getting sort of information about your APIs back into this sort of cloud security graph that you have there.
Yeah, and just on that logging point real quick, we just actually put a blog post live on our website to talk about the challenges of API logging and just how difficult it is even on one cloud provider where you might be running APIs behind application load balancers, API gateways, WAFs, et cetera. And there's so many different log formats and log types and log destinations. And so if you're really trying to understand the risks and the threats against your APIs, the importance of having it kind of all normalized in one location, you can, again, get a lot of bang for your buck by just, centralizing your log shipping and then your log analysis algorithm all on a kind of unified log stream. So check that blog post out. I think it's called The Challenges of API Logging. It just went live on the FireTail website a couple days ago.
For sure, yeah. And then the other thing that FireTail is very proud of is our inline libraries and different kinds of modules for dealing with on-prem or application layer security. So this is another aspect for basically making sure your operations are running a secure API, where the libraries are using the Open API specification that you have to do centralized validation, centralized sanitization. For some of the languages, we even have extensions that will do authorization in a similar way as normal authentication can already be handled by Open API spec. So this helps you with policy enforcement and making sure that there are no accidental data leaks, for example, with sanitizing and stripping out data that shouldn't be in response payloads, for example, making sure that all of the items in a response payload are authorized, etc. So this is really like what we see like the penalty or the ultimate step in customer adoption when they start using the FireTail libraries to make sure that they're actually then running the APIs securely. And these are definitely intended to be tools that make developers' life easier, make them be able to focus on actually writing the business logic of the APIs, not needing to spend tons and tons of time for making boilerplate code around, validating request parameters endlessly for every single endpoint, etc. this is one of the main sort of benefits that you do get from starting to use an open API specification, is this sort of developer focused tooling. All right, finally, let's quickly look for decommissioning again. And here, just sort of the main fact here, how FireTail can help you, is that when you integrate FireTail in your cloud environments, when you integrate FireTail within your code repositories, what we do is we find these APIs and we connect them up together. So then we can start alerting and informing you about mismatches, like a code repository has gotten pushes and it tried to deploy, but the changes are not showing up in the cloud, or a cloud endpoint or cloud API resource was removed and suddenly is coming back in, or there might be instances where an API didn't receive logs for quite a long time and suddenly there's an influx of logs again. These sort of things make it easy to identify, zombie IT, things where dev instances were kept running and suddenly are connected into prod resources. There are sad stories about these sort of things causing really bad incidents. So that's basically it for me. I'm handing back to Jeremy. I hope this was informative and helped you get an idea of sort of what items and things are in the CIS security guide, what topics are broached, and gave you an example of how to use a tool like FireTail for addressing these.
Awesome. Thank you so much for going through that, Timo, and thanks to you and to actually the whole team that worked on this from our side. I did want to call out a couple of other people that we didn't mention at the top and really should have, but Deborah, our technical writer, and Victor, our security researcher, as well as Riley, our CTO, worked with Timo on this. And so huge kudos to the whole team for working on this. Just a couple of final thoughts from me, and then we're going to get into questions from the audience. So what do we intend as next steps here? Well, this is out there. This is a free, publicly available resource available to really anybody. You don't even need to have a CIS account in order to kind of download the guide for yourself and check it out and see if it's the right fit for your organization and can provide that guidance that we talked about at the beginning. If you do want to contribute, that is very much welcome and invited. For that, you will need to sign up for a free CIS account in order to join the community and do that. The URL for that was on the slide earlier. If you're watching this webinar and if you registered again, you're going to get these slides. The URL is included in there. You can also just kind of go Google it. You'll find, if you just Google CIS API Security Guide, it should come up and you should find the community and so on. What do we expect to happen? So currently, this is kind of the initial release of the guide. We do expect there to be community feedback, as there already has been, even just in the couple of weeks since this was first announced. And so probably there will be some incremental revisions. I don't know if that's going to be a guide 1.1, 1.2, or if that'll be a guide 2.0 next year. We'll have to see how that shakes out. And that's honestly a process that CIS manages together with the community. It could also very well be the case that this initial guide does turn into various API security benchmarks for the particular technology platform. So it could very much be the case that, a year or year and a half, 2 years from now, there is an API security benchmark for running APIs on AWS, as an example. And then from an industry perspective, we actually do expect to see regulation coming into this space. I was talking to a longtime CISO from a large bank here in the US, which is a very heavily regulated industry, as everybody might expect. And what he shared with me was that typically once you start to see regulatory guidance and action around one regulated industry, it tends to spread to the others pretty quickly. So in this case, it might have started with telecommunications, but you should expect to see more and more regulatory guidance around API security if you're working in, whatever, financial services, healthcare, government, insurance, whatever other industries might be regulated where you live. So with that, we're going to go to Q&A, and I'm actually going to go to the next slide for anybody who wants to the slides you're going to get via email anyway. You are also going to get, as I mentioned, a link to the recording of this podcast, as well as a link to download the API, the CIS API Security Guide for yourself. So that's all coming via email. So you may not need to worry about the QR code on the left-hand side as much. But for anybody who actually wants to try this out, try out FireTail for themselves, you can just scan that QR code on the right-hand side of the screen. And let's take some questions that came in. Okay, first question that we got here. how should we prioritize the different security controls in the API security guide, particularly for legacy systems with limited resources? So I guess this is a question around kind of prioritization of all the different stuff that's in there. So Timo, do you have any quick initial thoughts on that one?
Yeah, so if you've got an existing legacy system, then obviously the sort of most important thing is to ensure that like operational controls around authentication authorization are in place and working correctly. Whether this means, that you need to start logging and sort of looking at your logs closely, whether you need to make like a code review, that is sort of dependent on the situations. But as we already pointed out, like authorization failures are the main sort of ingress road to bad people abusing your API. So this is like definitely the most important thing. Right after that, I would encourage you to start working on an API specification and sort of figure out how to incorporate that. Even for legacy systems, it's well worth the effort to put that in there, and just for documentation itself, but also for the many different things good documentation enables.
Yep. Okay. And by the way, I am aware we're just a minute or so over time right now, so we're going to go rapid fire on some of these other questions. We've got just a few more to try to get through. So given the growing complexity of APIs in their integrations, how do we balance security and API performance? So basically, just to summarize, it's what's the trade-off in the balance between security and performance?
I would say that is a false dichotomy. Like well-managed security improves performance. Having an open API specification to drive your development process increases efficiency. Centralized validation, centralized sanitization just makes your code run faster. I think that's
Yeah, look, I would generally agree with you. The only thing I might add in there is I know for some organizations, they're very cautious about putting anything extra or any extra code into their API, even if that does give them, let's say, additional layers of visibility in their log files and whatnot. But you don't have to. You don't have to make that trade-off.
Yeah, they need to put an intern on it and see how much code they can delete. That's
Fair enough. All right, next question. Okay, what factors should we consider when setting rate limits to avoid disrupting legitimate traffic?
Yeah, so this is a very broad question, I would say. Obviously, you should start with getting some monitoring in place first. Get like a good baseline for normal behavior and then start doing rate limiting. You might want to do soft rate limiting first. And obviously, when you implement rate limiting, you should have internal notifications set up when those trigger, just to make sure that everything's going okay.
Yeah, I think that's a really key point. And it's so funny because like, well, just to take like a slight tangent for 10 seconds here, like when we started FireTail, we were kind of on the fence about whether anomaly detection was a good algorithm to think about in terms of API security, but that's absolutely a use case where it really is a good thing to look at. Okay, great. In terms of compliance, how does the API security guide align with existing regulations like GDPR or HIPAA, particularly regarding data protection and privacy? I mean, pretty much separate, right?
Yeah, I think like this is definitely more sort of focused around operational controls for the whole API lifecycle. Sort of existing regulations usually takes a look at specific aspects of data security, like privacy, for example, with the GDPR or transparency.
Yeah. But by the same token, I mean, if you follow what's in the guide, you should have better data security as a natural outcome, right?
Yeah.
Makes a ton of sense. For organizations using third-party APIs, what steps should be taken to ensure that those external services don't bring vulnerabilities into your environment? Again, pretty separate.
Yeah, and it's like a huge thing. So, but I mean, again, documentation I think is key here. Like at the very least, have some transparent documentation available for all the developers around like this route is calling Stripe. Right, that makes everybody aware that, okay, when I'm writing code on this particular endpoint, I need to be extra careful because it's a high-risk endpoint, right? That is a good example. But it's a really tricky problem.
Okay, and last one that we've got here, unless there's any last one or two that trickle in here, but how can we integrate the recommendations from the guide into our existing DevSecOps practices? Well, just how can we integrate recommendations from the guide into our DevSecOps practices?
Yeah, well, go to the CIS workbench, download the guide, and have a meeting with your leadership team. Figure out if this is something that you want to do.
Yep.
Participate in the discussion. Call us up for a demo of FireTail. That would be one. But
Yeah.
yeah, it's the start of a process. Having an actual security strategy for your API is something that you need to decide, and then you need to just execute.
I think that
There's no easy out.
Yeah, I think that point that you just said, though, is really the key. It's the start of a process, right? And look, the guide is designed around the API lifecycle. So if you kind of take that lifecycle and you kind of, let's say, lay it side by side with your DevSecOps process, you might find what the logical, like natural starting point for your organization is. And it might be all the way in the kind of code and design phase, or it might be further right in the kind of, measurement phase. And then you figure out like how you kind of go through that process of integrating either step by step, process by process, phase by phase, whatever that might be for you. But it really is it depends on your organization.
And there's tons of low-hanging fruit. Like, do you have logging set up? Okay, set up logging. Do you have a documentation? Okay, put somebody on starting to document your APIs. It doesn't have to be an all-at-once solution either. You can do things step by step and work yourself toward the goal.
Yeah. Awesome. Well, with that, I know we went a little bit over time. Thank you for your patience for everybody who joined us on today's webinar. Hopefully it was worth the time. We got it to go into a lot more kind of discussion and examples than when we had previously kind of introduced this at Black Hat, where we were really time constrained. So we appreciate you taking the time to join us here today. Again, if you register for the webinar, you will be getting an email with all of the resources that we mentioned, the guide itself, these slides, a link to this recording. If not, if you joined us late, please feel free to reach out to us for any of those resources. Otherwise, you've obviously got the link to the recording. Please share around. And if you have any questions, just reach out to anybody at FireTail at any time. We'll be more than happy to help you. And we hope you find this valuable. And we hope, above all, that you find the CIS API Security Guide useful to your organization in terms of sparking an API security initiative or giving you guidance on taking one forward. So with that, Timo, thanks again for your time, for joining us today. On behalf of the whole FireTail team and everybody who worked on this guide, and to our partners at CIS, thank you for working with us on it. We'll talk to you next time. Bye-bye.
Yes.
Public streaming has stopped.